All right, guys, this is the first time I've done this with the document cam this way, so we will try our best on this one. So you guys should see this paper here. This is the same one that was in the slide that I was showing you guys. I just printed it out so I can write on it. That's easier for me. And then I also just have a periodic table. This is the chemistry reference sheet, California standard one. But anyone will get you at least pretty close to the number for doing these. Okay, so I will be referring to that as well, and I'll try to stick it in the camera when I can. Okay, so we've got the element symbol and then atomic number, number of protons, number of electrons, and mass number, number of neutrons, and then the isotope symbol. So I'm going to go through all of these. Once you get the hang of it, you guys can stop watching. This is just for your help. All right, so for the atomic number, if I know the name of the element, then I can find the atomic number. So what I do is I come over to my periodic table, and zinc is right here. So that tells me that my atomic number is 30, okay? My atomic number is 30. So I'm going to write that in right here. And remember, guys, as soon as you know the atomic number, boom, you know the protons, okay? Always identical, always identical. So now it says number of electrons. I do not see any charge here. It doesn't say like zinc +1, +2, anything like that. That means that my protons are going to be the same as my electrons. Okay, moving over, it tells me my mass in this case, so it says 65. So if I have 65 for my mass and I have my protons, I subtract to get my neutrons. So 65 minus 30 gets me my 35 neutrons. I'm doing this math in my head, so bear with me. All right, so then for the isotope symbol, what that means, first of all, the Zn is going to be significant for that symbol. So the Zn is my symbol for the element. So I put that like that. And then typically you can have a kind of a hint down here. Whatever is the mass you put on the top and whatever is the atomic number you put on the bottom. So my mass in this case was 65. So I put that on top. Sorry, maybe I should switch to pencil. And then my atomic number was 30. So that's what goes on the bottom. If you guys are typing these in, it's okay. Like if you put the 65 in first and then the 30, I'll understand that you mean 65 on top and 30 on bottom. You don't have to like try to figure out doing subscripts and superscripts and anything like that. Okay, this next one, notice that I don't know the element yet. I only have this 80 and this 202. So at 80 and 202 is all I have. Sometimes that can be tricky, but I'm going to use the electrons and hope that the electrons are the same as the protons. Okay, so I'm going to look at my periodic table. If there's no plus or minus sign, and usually if it's not indicated, it would be that would be true, that it would just be the same, the regular one. Okay, so I found that 80. We said it was our electrons. I'm hoping it's the same as my protons. So I think it might be mercury Hg, mercury Hg. And logically, that's probably a good guess since the 202 was close to the mass I saw on the periodic table. So that means I have Hg here. And remember that if we said we have 80 electrons, if there's no charge over here, then we must have 80 protons as well. And that's our atomic number. So a lot of times those are going to be the same as long as we don't see a charge. Coming over here to our neutrons, okay, remember that we take our mass minus our protons. So in this case, 202 minus 80, that's going to give us our neutrons. So 202 minus 80 gives us 122. Lastly, we just need to do the symbol. So mercury, we already said was Hg. And we put the mass number on top, which was listed here. Notice I did not copy the mass number from the periodic table because this is not the version on the periodic table. And then the atomic number under. Okay, moving on again. When you get the hang of this, you can stop watching. This is just for your help. So germanium, Ge. So again, I find my Ge on the periodic table. And it is right here, Ge. So it tells me the atomic number is 32. So I'm going to copy down my atomic number of 32. Because there's no charge here. Well, first of all, I already know my number of protons. Atomic number of protons always identical. Because there's no charge listed here, that also means that I have 32 electrons, okay? 32 electrons. Now, this time, I don't have the mass number. I need to figure out the mass number. I do not just go look at the periodic table because that could be a different mass. This could be an isotope, okay? What I'd have to do is go backwards. Normally, we do mass minus protons equals our neutrons. We can also do protons plus our neutrons to get to our mass number. So 32 plus 44 should be 76. Okay, 76 would be our mass. And then again, for our isotope symbol, I have that Ge. On top is my mass, my 76. And below is my atomic number 32. Okay, moving on to my next one. I don't have a symbol here. I just have 115 and 48, but 48 is a big fat hint. So I use my periodic table, and again, you guys have one online, and I find the 48, which is right there. There's the 48. Tells me it's cadmium Cd. Cadmium Cd. So now I know the element symbol, Cd. Atomic number of 48. That means I for sure know my protons. That's the easiest one to fill out. Because they didn't give us any charge, we're assuming it's neutral. They have to give us a plus or a minus if it's not neutral. So that means that my electrons are going to be the same as well. All right, again, over to our neutrons here, our mass minus our protons. So we're going to do 115 minus our 48, and that is 67. That's how many neutrons we have. Lastly, we write our code, our isotope symbol code, CD, and it is, you can't really tell with my handwriting, but it's a capital C. The first letter is always capital, second letter is always lowercase. My mass of 115 on top, and my atomic number of 48 on bottom. All right, next one here, the only information we have is the isotope symbol. So we already know which element it is, so I'm going to slide over and plug that in, Xe, xenon. Okay, and then don't forget that this automatically tells you some stuff. That 133 tells me my mass number, and that 44 tells me my atomic number. I don't see any charges listed anywhere. Well, first of all, it has to be the same as the protons. I don't see any charges listed anywhere, so my electrons are the same as well. And then lastly, to find my number of neutrons, remember that's 133 minus your protons. So 133 minus my 54 protons gives me 79 here. Okay, one more to go. We've got beryllium. So I come over here. Beryllium is right here with the atomic number of 4. So that's what I put here. That has to be my same number of protons, okay? Those always have to be identical. I notice that my electrons are not the same, okay? Now this is the first one that I have a difference between my protons and electrons. So that's going to help me to figure out my symbol at the end, okay? So let me go to the mass first. If we want to do neutrons, 9 minus 4. Again, 9 minus your atomic number or your protons. So that gives me 5 neutrons, okay? Now come over here. I'm still going to use my BE for my symbol. I will try to write small. And then my mass was given to me. That's the 9. We found out my atomic number was the 4. But for the first time on this worksheet, I don't have the same number of protons as electrons. So I have to factor in if this is going to be a positive or a negative, and how many positive and how many negative. Okay. So the first thing I notice, that's the total number of electrons. That means that that's energy levels full. That's that inside level of the electrons. So what happened is normally I would have 4 electrons, and I got rid of 2 electrons. So now that I have 2, I got rid of 2 electrons. They're negatively charged. That means I actually have a positive charge, plus 2. I lost 2 electrons, so that makes it leftover positive. Electrons are negative. So if you're taking away electrons, the leftover protons are going to be more, like there's more protons than electrons, so that's how you get a positive charge. If there's more protons than electrons, it's positive. If there's more electrons than protons, it's going to be negative. So that's kind of another way to look at it. More protons than electrons, got to be positive. What's the difference here? 4 and 2? Well, there's a difference of 2, so positive 2. That positive or negative part is probably the hardest things of doing this whole procedure. So if you do need help, you can always reach out, but hopefully this helped you. Have a great day.